Okay, here we go. Practice test 3. Last one. Again, I'm not going to take the time on the video to work these out. They're all worked out on the answer sheet, which you already have. So it's your responsibility to make sure you can type them in on your calculator and get the correct answer. Here we go. Number 1. I have 10 jumpers and 12 shirts and two pairs of shoes. I'm going to wear a jumper, a shirt, and a pair of shoes every day, so that is 240 different outfits. 8 people around a campfire. Remember, we talked about this in the last couple of videos. If you have 8 people in a row, it's 8 factorial. If you have 8 people around a circle, it's 7 factorial. Always one less when we are arranged in a circle. We have 10 multiple choice questions, and each question has 3 options. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are my 10 questions. Each question has 3 options. So there are 3 ways that I can answer this question, and 3 ways that I can answer this one, and this one, and this one, and this one, and so on, and so on, and so on. So my answer, since there are 10 questions, is going to be whatever 3 to the 10th power is, because I am going to multiply 3 options times 3 options times 3 options 10 times, because I'm going to answer question 1 and 2 and 3 and 4 and so on. What is probability being dealt a 5-card hand? So we're back to a 5-card hand with exactly 4 hearts. Now, if you are a 5-card hand and you have 4 hearts, then that means you have 1 card that is not a heart. So you have exactly 4 hearts. So I have 4 hearts and 1 other card. Okay, there are 13 hearts, and I'm going to pick 4 of them. There are 13 hearts, and I'm picking 4 of them. And I need 1 more card, but it can't be a heart. So it's got to be a diamond, club, or spade. Well, there's 39 of those. That's a 39. And I'm going to pick 1 of them. So I'm taking 4 of the 13 hearts and 1 of the 39 other cards. Divided by, this is a 5-card hand, 52C5. Now I want another 5-card hand, so my denominator is going to be 52C5. But this time, it's all face cards. Okay, so I have a jack, a queen, and a king. Those are my face cards. And I have 4 suits. So I have 3 of each suit. There are 4 suits, 12 face cards, and I want 5 of them. There are 12 face cards in the deck, and I want all 5 to be face cards. So 12C5 over 52C5. Number 6. I have 80 seniors all together. All of them enjoy matrices or vectors. 48 say they love matrices, and 42 say they love vectors. All right, that's 90 votes. So I asked these kids, who likes matrices, who likes vectors? 90 kids responded. That means, since there's only 80, 10 of them responded twice. They like both. So since there were 48 total in the M ball, that leaves me with 38. Since there were 42 total in the V ball, that leaves me with 32. Question was, how many like only vectors? Only vectors would be that number right there. Those are the people that like only vectors. Okay, now I've got 5 Republicans. Oh wait, no, that's what I'm picking. I have, in my group, I have 10 Republicans and 7 Democrats. And I'm going to reach into this pile of people and I'm going to pick 5 Republicans. So Again, there are 10 of them, and I'm picking 5 of them. Is it a 10P5 or a 10C5? Well, that depends totally on if order matters. If I'm picking these people, just picking them for a committee, order does not matter, so that's 10C5. There are my Republicans. And I am picking 3 Democrats. So 7C3, 7 Democrats total, picking 3 of them. And I'm going to multiply those because my committee has Republicans and Democrats. How many ways can 4 unruly students be lined up in the hall? I have 4 kids, I'm lining up in a row, that would be 4 factorial. If I had 4 kids and I lined them up in a circle, that would be 3 factorial. How many ways can I give 5 identical pencils to 5 different students in a class of 8? So I have 8 kids and I'm going to give away 5 prizes. But the prizes are identical. So does the order that I give them matter? No. So this one's going to be 8C5. If the prizes were different, it would be 8P5 because then order would matter. You would care when you got picked. But if the prizes are all the same, nope, we're just 8C5. We're just picking 5 people. All right, now we have the word calculator. And we want to know how many ways we can arrange those letters. Step 1, always 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 letters. So we start with 10 factorial, always. However many letters you've got, that's what you're going to start with. Now, are any of them repeaters? Well, I see 2 C's, so I'll divide by 2 factorial. I see 2 A's, so I'm going to divide by another 2 factorial. Oh, there's 2 L's, that's a 2 factorial. And that looks like it's it. So again, when I type that in on my calculator, make sure that you put parentheses around that so that you are dividing by the entire denominator. You have to divide by all of that as a group. All right, if it rains, Tim's going to do homework. If it doesn't rain, he's going to do homework. 10% chance of rain. What is the probability that Tim will do his homework? So the question is homework. So the first tier of the tree is going to be rain or not rain. Because the bottom tier of the tree is always the question. So that's homework or no homework in this problem. If it rains, the probability Tim does his homework is 0.65. So that's a 0.65, and this would be a 0.35. If it doesn't rain, the probability is 0.32, which would be 0.68 for the no homework. There's a 10% chance of rain tomorrow. So there's a 10% chance it's going to rain, which means there's a 90% chance it's not going to. What is the probability he'll do his homework? He can do his homework here, or he can do his homework here. We need the probability of those branches. So rain and homework would be 0.10 times 0.65. And I'm going to type it in. You can do that. That's rain and homework. Or no rain and homework. So you're going to get that number, and you're going to get that number, and you're going to add them together, and that's going to be the total probability of him doing homework. Okay, now we have an expansion. Now this is one where we have to do the whole row. We're expanding the entire row. So I happen to know that the 5th row of the triangle is this. Again, I have it memorized because I'm a teacher and I do this for a living. That's the 5th row of the triangle. Next to each of those, I'm going to put a 3x and a negative y. a 3x, and a negative y. Now remember, these are individual terms. These are individual terms. You've got a bunch of individual terms there. And we still need to put the exponents on. So we're going to the 5th power. So the first power on the x is going to be 5. And then down we go. 4, 3, 2, 1, 0. And then 5, 4, 3, 2, 1, 0 on the y's. Now we're going to look at each term and simplify. So each of those individual things is going to get simplified. Remember that anything to the 0 power is 1. So I have 3 to the 5th, x to the 5th. That's 243 x to the 5th. There's my first term, 243 x to the 5th. Now I've got a 5, an 81 x to the 4th, and a negative y. Now that's not a subtraction, that is a multiplication problem. So that gives me negative 405 x to the 4th y. 5 times 81 times negative 1. Now I've got a 10, a 27x cubed, and a y squared. That's going to be positive because you're squaring out the negative. So that's going to be 270 x cubed y squared. Now I've got a 10, a 9x squared, and a negative y cubed. That's a negative 90 x squared y cubed. Again, this is not a subtraction, this is a multiplication problem. 10 times 9x squared times negative y cubed. 15x y to the 4th. 5 times 3x y to the 4th. And minus y to the 5th, because anything to the 0 power is just 1. There it is. You'll have your calculator, so there's no issue. You'll have your calculator, you'll be able to do that. All that multiplication. Now the next one, here's that 5th row that we just used. Here's the 6th row. And the 7th. And 10. I'm going to stop right there. Now, I could start with the 5th row because I have that memorized. We are doing the 3rd term of 2x minus 3y to the 10th. So I found my 10th row. Now, I'm going to mention again, because I mentioned this once before, but I don't want anybody to get confused. This will always work. Yes, it takes a little bit of time, but you are going to get the right answer if you do this. These numbers in this in any row you want, but if I'm looking at the 10th row, this is 10C10, this is 10C9, so this number would be 10C8. So if you want to get the numbers using the combination numbers, you absolutely can. It will work every time. You just have to make sure you count right. But that number would be 10C8 if you didn't want to work the whole thing out. We've talked about that before. Okay, so I've got my 45. That's the 3rd term. That's the one I want. It says find the 3rd term. I want the 45. I didn't bother writing out the rest of the row because I don't care about the rest of the row. I want the third term right here. Next to that will be a 2x and a negative 3y. Now the power on the 2x, I have to count down. So here it would be 10, here it would be 9, here it would be 8. By the way, we talked about this in class 2. That number right there, if you do this as combinations, 10C8, that's going to be your exponent right there. If that's an 8, this is a 2, because those have to add up to 10. So I have a 45, I have a, oh gosh, 2 to the 8th. I have a 256, x to the 8th, and a 9y squared, negative 3 squared. And all that's times each other. So 256 times 45 times 9, that term is 103,680 x to the 8th y squared. There is the third term of that expansion. Now I want to do 8C5 by hand. So remember the rule. By hand, it's 8 factorial divided by 5 factorial, 3 factorial. It's that number divided by that number, and also divided by the difference of these two numbers. There's two numbers in the bottom. So 8, 7, 6, 5, 4, 3, 2, 1. Divided by 5, 4, 3, 2, 1, 3, 2, 1. 5 factorial, 3 factorial on the bottom. So everything from 5 down is going to cancel. This looks familiar. I think we've done this before. 3 times 2 times 1 is 6. That cancels with that. And the answer is 56. Now we've got some m's and some n's. And we know the probability of m is 0.62, the probability of n is 0.75, and the probability of m and n is 0.51. This is m and n right here. That means both. So this is 0.51. But the whole m circle is only 0.62. So this has to be 0.11. And the whole n circle is only 0.75. So what is that, 0.24? Now the questions, there's two questions. We want the probability of m and not n. This is m and not n. So what's the probability? You're in the m circle, but you're not in the n circle. That would be 0.11. And then we want the probability of not m and not n. So not m and not n. Okay, not m and not n. Okay, now wait a second. That would mean you're out here. Well, I haven't found that number yet, have I? Let's add these up. We have 0.11 and 0.75. So that's 0.86. So inside the circles, I have 0.86, which means outside the circles, I have to have 1 minus that, 100% minus 86%. So the probability of not being in either circle is 0.14. All right, now we've got another one of these problems where we've got class 1 and class 2. We're picking a kid out of each class, so we are going to be multiplying. All right, both like English. That means I got English in class 1 and I've got English in class 2. That is 0.06. First likes math, 0.6. And second likes art, 0.1. 0.06 is the answer to that one also. First kid likes math, that's class 1 likes math, class 2 likes art. Neither likes science. So look at class 1. You want everybody but science. So that would be 0.9. And then in class 2, you want everybody but science. That would be 0.8. So that's 0.72. D is the tricky one because we don't know who's coming from where. All we know is that we could have science and math. So science out of class 1, math out of class 2. Or we could have math and science. So that tells me I'm going to be doing an addition. All right, let's do science and math. So science out of class 1 and math out of class 2. So that would be 0.04. Or math out of class 1, that's 0.6. And science out of class 2, which is 0.2, that's 0.12. So math out of class 1 and science out of class 2. So my answer would be 0.16 because I need to add these together because it could be this situation or that situation. And that's the end of that. So good luck on tomorrow's test. Have a great day.